Hello, everybody. Welcome to another episode of the Business Spotlight. I am Scott McMeans with Action Coach, and I'm here today with Todd Doehring from ABÄMIS. I can't even begin to explain to you how amazing this company is because they do things that no other company can. So before we get into all those details, I'm going to let Todd introduce himself. So Todd, please introduce yourself. The camera and the microphone are yours.
Oh, hey. So I'm Todd Doehring, and I'm a bioengineering graduate from University of Pittsburgh, Musculoskeletal Research Center, and I've been working on various different biologically inspired structures for optimization in mechanical components and trying to make the optimal structures that see, I'm tongue-tied, but the optimal structures that we can achieve using new additive manufacturing methods. I mean, I've been working on this technology for, I don't know, 20 years or so. And yeah, and we started out working with like lattice type structures. It's the same as like a bridge, like the lattice,
Yes.
and trying to use those types of structures in order to make motor mounts for our microscopy systems. So with microscopy, anti-vibration and light weighting of motorized components is extremely important. I mean, in the I think it was the 2021 microscopy, the major microscopy convention. It was funny because the the first prize award for the best technology wasn't a microscope. It was a vibration isolation platform.
Okay. And
Yeah.
to your point earlier, I think when we were talking, the vibrations within using a microscope, it can distort the image and it can take the image longer to bring itself to resolution, right? So you want better clarity and quicker time to get to a good image. And when there's too many vibrations, whether it be from the motor mounts or the motor that's moving the microscope back and forth, you get those vibrations. And what you're able to do with the ABÄMIS is build these unbelievably unique structures that have a contoured outward shape, but inner wise, you don't have a lattice that is repeatable. The lattice structures that you 3D print are actually vibration containment in such a way that there's no easy one directional or two directional path from one point to another for vibrations to travel. It actually has to go through this matrix of un of unique qualities and unique designs, so the vibrations get dampened and canceled out. Is that the best way to explain what you do?
Yeah, I think that's a very good explanation.
Okay.
I mean, all of the struts of our structures are semi-randomly oriented. So because of that, then they vibrate in semi-randomly oriented ways, and all of that just cancels out. And
Yeah, and
the other thing
one of
that
the
our
things I thought
structures
was
can do here,
interesting.
let me
Yeah,
just
please grab the structure so people can
well,
see what we're talking about.
it's not just that though. Our structures are extremely conforming, conforming in ways that there's no possibility of generating the structure with a lattice. It can't be done
Right.
because of I mean, this is a completely continuous structure.
Yeah, so
So
the outward shape
having
is
complex
um,
geometries like this and having the ability to generate them is the key factor,
yeah.
because that is the only way to enable an artificial intelligence optimization algorithm to be able to have the variability to generate all kinds of different structures. With a lattices, you're extremely limited. Like if you take a lattice and then you curve it together in the middle, the the number of lattice elements that you would need is infinite.
Yeah. Because
So that
whatever is
doesn't
the
work. Like for instance, like here, it would be impossible to do this with a lattice. Not even close. I mean, this is completely
So cool.
conforming, and a completely manifold printed object. So we can do
What I
this, and we can
Todd, what
do
I
all
think
kinds
is
of,
so unique about what you do is the structures are outwardly, the shapes are recognizable, but what is done on the
yeah,
inside is what makes it so unique. Again,
right.
looking
And so
at
you
that,
can see
there's
on the
not,
outside, it looks, it has a, it kind of looks like a little bit like a truss, but
yeah,
on the inside, all of the struts are semi-random. So I don't know if I
yeah.
have too many examples. I've been accused of using too
What I
many.
think is neat about that, Todd, is the only 90 degrees on that structure are the outward edges, right?
That's correct.
Everything
And
else is
and it's 100% conforming to that structure. So for instance, if somebody like Boeing has a component for an airplane seat, and that component for the airplane seat is made out of cast aluminum, and it weighs, you know, 300 grams. We can 3D print that same component. Basically, all I would need is the outward CAD file. We transform it to a hyperstructure, and we can save them. We can probably get that down to around 70
that
grams,
is what is
70 or
so
80 grams.
unique. Yeah, that
Yeah,
is what's
not
so
just
unique
like
about this.
the difference between 400 and 390, but we can probably get it down to 70, 80, 90 grams. So
Yeah.
that you can extrapolate that concept to all kinds of other applications like aerospace, sports, impact, military, you name it. I can name more, but
No,
it would
that's
take the rest of our entire interview.
because typically what I ask people is what markets are you interested in? And you have an infinite number of markets you can go after because of the design capabilities of what you have with your very unique capability of being compliant to an outside shape, but uniquely designed inside that shape to one, build strength, and two, minimize vibration, which is just an amazing part, especially when you're thinking about the weight component of everything that goes into everything we use.
Absolutely. Yeah, we've got
Automotive.
those two major advantages is ultralight weighting and anti-vibration. I mean, this thing feels like a stone. You can maybe even hear that.
Yeah,
It doesn't sound like a piece of plastic that would ring if I banged on. No, it sounds like a stone.
it's
And
pretty
that's the
impressive.
whole point. Yeah. Yeah.
So
We published a paper in Nature on this about 2 years ago. Now, at this point, it's been like 2 years. And I think I've sent you that information.
yeah,
And we have a patent on this technology. We have two now. So our second patent just got approved, I don't know, 4 days ago.
oh,
And
that's so exciting.
that's for applying the artificial, because if you can make a structure like this, then you can generate, what we do is we generate giant training data sets. Like I can make any variation of a structure like this, or an aerospace component structure of some sort. And then we use that to train the AI, and then we give the AI a goal. The goal is, it is in text, it would be optimized end connection boundary conditions for this amount of load.
Yep. So you
And
can
then
dial in.
it will use the trained database that we generate to generate those types of another range of structures, and then we test them. We just 3D we print them.
It's insane.
Yeah,
It's so cool
and
because
so maybe it's not the best one, but we can print. I can print like 10 in 2 days, and then we can test them and see which one works the best. And then we
there
tell
you
the
go.
AI which ones works the best, and so it becomes a feedback loop.
Smarter.
Yeah, yeah.
So to try to describe what a ABEMIS is, the best way, and we've had this discussion, is to say you're a component design and development company that can work with any outward shape and any market to build a lightweight, structurally sound component. That's what you guys do at ABEMIS. So what I'm trying to get to is what are the interesting parts of your interactions with your customers that you'd like to share? Like what is it they're looking for when you provide your service, and how is it that you're able to produce the things you produce for your customers?
Oh, well, I think that, we're very early in this process. We only really started working as a startup on this technology about, right during the pandemic. So
Yeah,
our clients, like, for instance, I'll give one example. Philips Respironics or Philips Medical, we design face masks for them, and these are for CPAP machines. So the current face masks for CPAP machines are just sized. It's like a shoe
yeah,
where they have size 8, size 7, size 6, 5. But it doesn't and they might have a couple things like narrow or less than narrow, lesser narrow, like medium width and stuff like that. But the idea with this project, it was that they have a whole database of scans, which they provided to us. We've been through contract negotiations, and they provided this to us, and we generated various different shapes using hyperstructures, using these types of structures,
yeah.
and flexible. So we're printing them in sort of like a silicon type material. So they're very flexible. And that means that they conform. And so they section up um, the groups and categories of people's faces into, I think, 7 or 8 groups right now. Like you've got male, female, um, thin, non-thin, and various different sizing. And then they match what our data provides them to those categories. So what the ultimate goal is for have the patient to come in, have their face scanned. It's very easy. You just use an iPhone, have the face scanned, match the exact type of face mask geometry to their optimal need. And then it's printed using our hyperstructure technology. And we account for the potentially higher stresses around the rim. And so I don't have one to demonstrate to show you. I mean,
No,
I
I
have
do.
them here, but so that it's more comfortable and also more compliant, but it doesn't fail, like it doesn't fall off,
Yeah.
right? So
And
yeah, a very soft, it's extremely soft, much softer than their current soft versions, which are like a foam, a very
okay. And
very
what I
dense.
find
But
interesting is you're
our
able
our
to
structures
take
are like 10 times better. So
my very point was going to be you're able to take an existing concept or an existing design and add the right design components with what your capabilities are to build comfort and structural integrity into various areas. So one, it fits right. Two, it's comfortable. And three, it doesn't fall off in this application as compared to what it was before, because it was designed in a very
uncomfortable,
yeah,
extremely
very,
uncomfortable.
and the design of it before was very rudimentary. It didn't have a lot of capabilities like yours to build a structure with certain strength points at different areas or target points of the mask. Now you're able to do that because your design capabilities are allowing you to do that.
Yeah, and
Like,
it's not just our design capabilities. It's sort of a convergence of technologies because I mean we could have the best design technologies, but if you can't make it, then it doesn't do anything.
right,
But now with additive manufacturing, that's changed the entire game. I mean,
yeah,
we can generate our structures now in all kinds of different materials, from carbon fiber to aluminum, titanium, um, aircraft certified aluminum now from through a project that I'm working on at NASA Glenn Research Center. Um, there are all kinds of materials. Ceramics is one of my main interests right now. Microceramics. So
why
we're working.
ceramics?
Yeah, microceramics is a really interesting, like, overall topic where I think our technologies can really benefit that arena of modern additive manufacturing. So yeah,
So,
these are, you know, uh, I can't remember the exact name of the company.
That's okay. Just go ahead with what you're
Yeah,
trying to get to.
it starts with an L. Anyway, it starts with an L. And yeah, so we've got demonstration units back, which are very small. They're like tiny and ceramic and the same structure as this because
Okay.
they can condense down the spatial resolution of their printing technologies to amazing degrees. And ceramics are really neat because when you're 3D printing, when you have a regular ceramic, they break, they shatter,
Yeah.
they get brittle. But our hyperstructure technology breaks up the entire internal topology, and it makes it super light, and it's stiffer. It's actually more fatigue resistant.
And would it be less brittle because the points are
Correct.
so random?
It
Okay.
provides a little bit of give
Okay.
so that
Like,
cracks don't really, just like vibrations. When the ceramic cracks, that crack propagates wham really fast,
yeah.
right through the structure, bam. But with our structure, there's nowhere for it to go.
Yeah.
So it just stops.
It's it's really
So
remarkable how this design capability has come forward. What
check
I
it
want
out.
to ask you, Todd,
I'll run you one more.
please.
So not only that, if we attach electrodes to each side of a of a structure, just some foil electrodes, and then measure the conductivity, and especially if we put arrays on each side, then if there is a crack or if there's any anomaly, that will be that will be recorded by the electromechanical difference in the
Okay.
electrodes. In other words, if a crack happens, well, yeah, it's going to change it. And you can, if you use arrays, then you can localize where that change is because you have the exact mathematical topology of the structure. So that makes you can have passive arrays that sense if there is overstress or damage in the structure. And then you can use that as feedback to make sure that, okay, we got a little micro damage in this component. So we'll just reduce the stress on that component using, whatever. We're not going to, if you're thinking of a spacecraft, we're not going to use that thruster too hard
Yeah.
because we know that there's a failure in that. But that could actually just be an autonomous system that just, provides, the standard feedback. Anyway, I tell you, I'll
It's
talk too long.
mesmerizing stuff.
I'll talk too long. My
No,
wife
it's
is saying,
mesmerizing stuff.
shut up.
What I'm curious about when you deal with clientele, what are some of the challenges that you have getting a sale or getting a relationship with a
Oh,
customer? What are some of the biggest challenges that you have?
we have one big challenge, and that's what I just submitted the grant for. And that is that we don't have a packaged product. Like we don't have an actual plugin. I have all the code. I can demonstrate it for you, and I can provide it as a service. But what I can't do, and what a lot of the clients that I've been working with, what they want is they want me to send them an executable file, and then they run it, and it runs. They want to test it themselves
Okay.
with a software product. So I actually have it, but we've been waiting for our second patent to come in, and now it's in, and I've been moving.
No,
So it's
it's
exciting.
interesting. So
So
you're trying to
that's
sell
our biggest
something.
hurdle right now. We need to get our product, and it's going to cost money to get that from the code base that we have, which is incremental steps. Basically, it's a bunch of codes that you run in line. It's fully
Yeah.
automated, but you have to run it in line. And
Yeah.
it's not like a, a candy coated um, super nice GUI test program.
No, I think
But
your biggest challenge you have is you
once we
have
have
somebody.
that and we get funding to do that, then I think we'll be golden.
No, I think what what most people have a challenge with is they want something tangible that they can touch, feel, and test, but they don't get that until they engage with you, because the concept of what you're able to do is more important than the actual
Absolutely.
tangible piece,
You're totally on point there. Yeah,
right? So your biggest job is education and presentation of the possibility, and not necessarily so much a plug and play product to replace what they currently have, because you're thinking on a much different wave, a much different
well, wait a minute. Let's
line
just
thought.
make sure, because that's not exactly it. What the original question was, what do the clients that I've been interacting with, what do they
Mhm.
want? What they want
Right.
is for me to send them a functional working Blender add-on. So when they run Blender, they can run the add-on and they can generate the hyperstructure themselves with with
Right.
some limitations, of course, because it's a beta test algorithm, a beta test system. I don't have that right now. I had I had a programmer during the pandemic, that programmer went somewhere else. So, well, actually, back to Tanzania,
Wow.
Hobart. Yeah,
So
back to Hobart.
my thought was,
And I haven't, I haven't achieved funding yet in order to hire because I really feel like I need a partner here. I'm doing all the programming myself. So at this point, the mathematics, I have partners that are helping me with the mathematics of the
sure.
hyperstructure.
No,
But the
what
programming I'm doing myself. And I can do it, but it would be so much more efficient for me to like have funding in like the, I don't know,
no, this is what
20,
we're here
30,
for. We're trying to
$40,000
get you.
range to hire some contractors to come in and then spruce this up. And because the code I have designed it parametrically, and it's all completely automated. So making the plugin is actually easy. But an issue with that is that if I make the plugin and give it to somebody, then it's out.
Right. No, you're doing exactly
So you
what you
have to
need to
think
do.
about the licensing and how you're
Right.
going to manage the licensing.
Your two patents now that you have, the one that you can
Mm-hmm.
use to get this done, that's the key. What I was referring
Mm.
to was trying to sell a concept of what you do to a customer, because you're trying to say, like you said, to Boeing, I can save you 230 grams of weight
Mm-hmm.
if you look at this structure differently than what you currently have. And if you do that throughout the entire plane, how many pounds
How
can
many
you
other
remove?
components? Any other component can be
Right.
treated the same way. Yeah, you
So
can make, every component could be treated as a hyperstructure, but the limitation is additive manufacturing. And when does it make sense? Like some
yes.
components are like the outer shell of an airframe. No, of course not. The outer shell of an airplane is best just as a stamped or composite, shell.
Right, because of what
But
its function is.
but
Yes.
where the connectors are from
Yes.
the outer frame to anything inside, all bets are on.
Yeah. No,
Everything.
that's the thing. Because
Yeah,
the way I look at your business, it's more educational at the front end to show this is a concept that we can do that actually will replace what you currently have at a betterment. It's going to be lighter, it's going to be more structurally sound, not as many vibration, all those things that go into it. But you're trying to convince people that what they've always done forever is something that can be changed. And that's some of the biggest challenges most people have when they run a
absolutely.
business,
I mean, it's
right?
incredibly difficult to break into
Yeah.
the aerospace industry and in any way. And
Well, one of the things I really liked
yeah,
about your
so
website is
what do you do?
you have a great photo of an automotive application where you could change the structure that for struts and axles for a vehicle. Think about how much lighter weight and structurally sound a vehicle could be if they use this type of design methodology. It would be lighter on the
Right.
streets, lighter on, or better on gas mileage, more
And
structurally
so
sound. So there's a
let's
lot
talk
of
about
application here.
let's take a step back and talk about barriers. I mean,
Mhm.
what I feel like is, and I'm going to be a little what are you going to say, colloquial here,
It's
but
fun.
I really think that one of the major barriers that I've had is just that I don't know anybody. I mean, I'm here in Cleveland. There's no advanced manufacturing in Cleveland. I barely know anybody that does additive manufacturing at all. There's only one guy, Tim Simpson over at Glenn Research Center. That's it. That's it. Within a 100-mile radius. And Pittsburgh has more. And I often feel that if I just had the capability to walk into the door and you have to find the people, like in Columbus or Cincinnati, for instance, and possibly even Dayton. There, I just need to get in touch with the people who make the decisions on these types of critical issues. Like, okay, who's the this Aeroforce thing? It highly interests me.
Yeah. Arizona, the Arizona.
Arizona. Highly interests me. Maybe there are ways to get in touch with I honestly feel if I can just get in touch with these people.
I think you're right.
If I was in New York right now, I've already had like 10 people sign NDAs and do stuff, but it kind of fades away a little bit because I can't be there, and they have weekly meetings, and I participate in some of the virtual meetings, but I'm not there. And then they're working on other things, and it kind of fades out a little bit. But I guarantee you, if I was there,
It'd be a big difference.
Yeah, I mean, our technology would already be.
Well, let's do this. I want to wrap up. I want to wrap up our discussion by saying all the information to get a hold of Todd. No, all the information to get a hold of you will be in the description below. So I want everyone to get a chance to connect with you. And if you know somebody, make a connection. Let's get Todd what he needs, because at the end of the day, the stuff he's doing is going to change the way we live.
It can.
Everything from your car to your airplane to your home. There's so many different applications.
Publication. I mean, if anybody has a question about what we're doing, or read our Nature publication first. It's easy to read, I think, and it gives a pretty good overview of what we can do compared to other types of so-called lattice structures.
I love it. Todd, we've run out of time. I want to thank you for being here. This has been exceptional conversation and really educational.
Oh, well, thank you.
Thank you so much.
I feel like I talk too much. I should be listening.
You're great. We'll see everybody on the next episode of The Business Model.
Okay.